Hello and welcome. Today I'll be simulating my 32-bit right shifter and 32-bit left shifter using Xilinx ISC Project Navigator 14.7 and ISIM. So I'll just quickly make a new project and name it Video Simulation 1. Next. Since I'll be using ISIM, I don't need to make any changes here. My code is already ready, so I'll go ahead and add my source. So what my code basically does is that it takes in a 32-bit input and gives out a 32-bit output, and the 32-bit output can be shifted from 0 to 31 times, and this is chosen by a user interpreted 8-bit bus, which is basically can be a universal bus in the system. And since I need only 5 bits to perform the actual shift, I truncate the last 3 bits of that bit stream, and I get this warning here because of that. But this is actually helpful because if there is a universal 8-bit bus, it can be used for my module. And I don't need a separate 5-bit bus in the hardware for my module to work. So this warning is basically okay. I'll just quickly implement the design since I'll need it to perform a timing simulation. So this is done. I'll quickly jump to the simulation. I'll perform a functional simulation first. So I'll be forcing values now, and I've made some test cases ready for that. I'll be going with something simple at first. So there. So basically what the select line tell me that I need my input to be shifted to the left by 3 bits. Now that means this bit should come here and this bit should come here. Let's just check. 110. So yes, this is the 29th bit, the 30th bit and the 31st bit. Same as here. Let's try this for a value more than 31 and to check whether it works. Again, I have chosen a simple value. Run this data format. So there you go. So the second time, after truncating the last 3 bits, the value that I get is 0. So my input and my output should be the same, which it is. And basically why this happens is that after shifting the output 31 times, the 32nd shift is nothing but shift by 0. And that is why I am just choosing the first 5 bits and truncating the rest. That makes sense, as those are the 5 bits that determine actually how many bits I need to shift. And the same logic I've implemented for the right shifter as well. So this was the functional simulation. Again, I'll be forcing values. I'll take the same values. Okay. So basically, what is the difference between a timing simulation and a functional simulation is that the hardware is never perfect. So when you give an input to the hardware, the output is generated after some time. So there is a time delay. The basically the timing simulation takes care of this delay and shows you in the simulation. So Let's just quickly check how much delay have we actually got. So just use these cursors. There. So considering I've put my cursors right, I'm getting a delay of around 12.158 nanoseconds between the input and the output. That is what the timing simulation is actually for. Now I'll be showing you the implementation for a right shifter. Since my code is ready, I don't need to fill in all those details. I'll just simply copy paste my code. There you go. That's my right shifter. Again, I get the same warning here since I've not used the 3 bits. And it's synthesized. Let's just quickly generate the place and route files. So this is done. I'll quickly jump to the simulation. Functional simulation first. Again, I'll start with something simple. Okay, just run it. Okay, so yeah. So according to this, my output should be shifted to the right by 4 bits. That means these 4 bits, 1, 2, 3, 4, should go here. And I should be left with a 0, 1, 0, 0, 1. 0, 1, 0, 0, 1. And that's right. So this is a right shifter. I'll try it for another value, which will be greater than 31. Okay, this looks nice. Easy to understand. Just run it. Okay, so yeah, this should be shifted by 3, and these 3 bits go into here. So I should be left with 1, 0, 0, 1, 0, 0, 1, and that's right. So it works for inputs greater than 31 as well. So quickly close this and perform the timing simulation. Run this. There you go. So there is this delay. Let's zoom in more so we can calculate it better this time. There you go. So it is an 11 nanosecond delay this time. Let's just simulate once again for another value and check what is the delay that we are getting between the input and the output. This time I'll just go for a 0 shifted output. So there you go. So to calculate the delay, I'll just zoom in. There it is. So even though if it's a zero shifted output, due to the hardware limitations, it does take time, and the amount of time it's taking, it must be wrong somewhere. Just zoom in a bit more just to be sure. Okay, so the delay this time is 8.9 nanoseconds. That's nice. So there is a delay due to hardware limitations. That is what the timing simulation shows. So that was the left bit, the 32-bit left shifter and the 32-bit right shifter, both functional and timing simulations. It was very fun implementing the timing simulation part especially. And thank you.